Why don't we do a warm-up so that we can see why we even need the law of cosines to begin with? Yes. So let's say that we want to, let's say we have this triangle here. Let's call this 90 degrees. Let's say that this is like X there. Let's say that this is 9, and let's say that this is 32 degrees. And of course, your goal is to solve for X. So in this problem here, I don't need the law of cosines. I don't need the law of sines. In this problem here, we can just go cosine of 32 equals adjacent over hypotenuse. And then you can multiply both sides by 9. These cancel. So x would equal 9 times the cosine of 32. And if you type that in, you get 9 times cosine 32. And that's like 7.6. And if this was in feet, then this would be 7.6 feet, roughly speaking. So a little warm-up problem here. In this situation, we did not need the law of cosines. What about this problem here? What if you have something like this? And let's say that this is 11. Let's say that this is 5. Let's say that this is 70 degrees. And let's say that the variable is right there for x. So here, we can't use like adjacent, hypotenuse. That doesn't work because hypotenuse, that's like a 90 degrees, right? The hypotenuse goes with 90 degrees. But in this picture, I don't know if I have a 90-degree angle. Okay, well, we don't know. We probably don't if it's drawn to scale. So in this case, we need the law of sines. So the law of sines, based on the earlier lesson, you'd go sine of 70 over 11 equals the sine of x over 5. That would be the setup. And then we can cross multiply like we did in class. So that 11 times the sine of x equals 5 times the sine of 70. And then we're trying to get x alone. So what if we divide 11? What if we divide 11? This would be gone. So we'd have sine of x equals 5 sine 70 over 11. Now we want x to be alone, right? We want this to be alone. So we got to get rid of sine, but you can't just like cancel it. So what you got to do to undo a sine is you have to go sine inverse. Yes, yes, yes. Sine inverse. Because the sine and sine inverse, whoosh, whoosh, they're gone. And so what you'd have to do is go calculator on that list. I got it right here. Sine inverse 55, no, 5 times the sine of 70. Just type it in what you see there while you guys copy. And this is about, x is alone, and it's about 25 degrees. So for this problem, we use the law of sines, and the angle x is about 25 degrees. Done. End of story. Now, warm-ups are over. Let's now look at a situation where you would need the law of cosines, okay? So what if you got like that? And let's say that this is like a 5, a 6, and a 7. And let's say that you wanted angle x. If you tried to set up a law of sines, you would go, all right, sine of x over 6 equals sine of, whoops, I don't have any other angles because this is missing and this is missing. And not only that, the only angle that I have is not even known. It's a mystery, right? Law of sines works if you have at least one angle that you know. But dude, here, I don't have any angles. So for a situation like this, you need the law of cosines. So here we go. Law of cosines says this. Let's say you have a triangle where the angles are ABC, uppercase letters. And let's suppose that little a, little b, and little c are the sides. Uppercase for angles or vertices, and lowercase for the sides of the triangle. So law of cosine says this. Here are the relationships between A, B, and C, uppercase and lowercase. Okay. So it goes like this. A squared equals B squared plus C squared minus 2BC times the cosine of big A. Also, little b equals B squared equals A squared plus C squared minus 2AC times the cosine of big B. And finally, little c equals A squared plus B squared minus 2AB times the cosine of big C. So law of cosines, if you open up a textbook, you'll see three different equations, but it's really the same equation expressed three different ways. So how do I know which of the three formulas I should use? It all depends on what you're given. If I give you, so maybe don't copy, just watch. If I give you this green triangle with like a 2, a 6, and let's say a 7, and let's say that the goal for you is to find angle A, then if you want to find angle A, then I would use the equation that has uppercase A. If your goal instead was find angle C, uppercase C, then I would use the bottom equation because it has uppercase C. So that's how you know which formula to use. So let's do two problems where you have to use the law of cosines. Let's say like this. How about I go like that? Let's say that this is a 9. Let's say this is a 4. And let's say this is a 7. And your goal is to find angle B, which is right there. Excuse me. So we want to use the law of cosines that has angle B in it. So that would look like little b squared, A squared plus C squared minus 2AC times the cosine of capital B. And if you want, in your picture, we know that capital B is given. So like this would be little b. And then for the other ones, you could call that little a, little c. Little a and little c are interchangeable. It doesn't matter which one you call which. Now grab all this information and plug it into this format. For instance, little b is 9 squared, and this would equal a squared plus c squared minus 2ac times the cosine of b. So this is 81 equals 16 plus 49 minus 56 times the cosine of b. We can combine 16 plus 49 to get 65. Yeah, 65 minus 56 times the cosine of b. Now, watch this. Over the years, I've seen students where they go 65 minus 56 and they call that like 9. But nah, bro, we can't do that because that's not 56. That 56 is being multiplied with some stuff. So really, you can't combine these. Nope, that's not an option. Instead, subtract the 65. Subtract the 65 to the left-hand side. So take away 65 from 81, and that's 16 equals negative 56 times the cosine of b. And then why don't we divide both sides by the negative 56? All right, so why don't we divide by negative 56, divide by negative 56, because these cancel. And so over here now, we have cosine, we have cosine of b equals, we have cosine of b equals negative 16/56. Now we're done. We're pretty much almost done. We have one more step and we're done. We want b alone. The goal is to solve for b. So now to get rid of cosine, you got to do the inverse of cosine, which is written as cosine inverse. Cosine inverse, because cosine inverse cancels with cosine. That leaves you b alone. And I typed it in just a moment ago. And let's type it in again just to be safe. I get about 107 degrees, roughly speaking. So for this problem, law of cosines was used. And we got about 107 degrees. All right. And that's it, right? For this problem, our first main example, the goal was to find angle B. We did. It's 107 degrees. Done. End of story. We can move on. Or maybe a quick comment before we move on. So if B is 107, we know that this is 107 degrees. Now, maybe you can go pencils down and just ask yourself this question. If this is 107 degrees, how would you find this angle? How would you find this angle? Here's what you can do. To find either of the two missing ones, you could then go law of sines, which is less work than law of cosines. And then once you find that missing angle, you can find the third one by just making sure that the angles add up together to give you 180 degrees. Okay. All right, now how about we finish this video with one more example? Let's say that you have a triangle that looks like this. Let's say that this is 12. Let's say that this is 10. And let's say that this is 72 degrees. And your goal is to solve, let's say, for x. So I know that law of cosines in your textbook, it has A's, B's, and C's. This one doesn't. You don't have to have A's, B's, and C's. Really, it all depends on how you arrange things. If you want to make, if you want to feel more comfortable about this, I suppose you could call this like little a, and this would be big A, if you want to feel comfortable with this. And you could call this B and C or vice versa. It doesn't matter. But now I want to know how to improvise. Let's call that X and let's solve for X and then we can finish this video. So in this instance, if you arrange things carefully, according to the law of cosines, here's what you should get. You should get x squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 72. And I like this situation here because if you look while I type, I want you to look at the right-hand side of that equation. If you notice, everything on the right-hand side of that equation is just a number, right? You can go calculator on all of the right-hand side. And if you do, you get about 169.835 and some change. The whole right-hand side is a number. The left-hand side is x squared. And now we can get x alone by merely square rooting both sides. And final answer, x is about 13.03 units. The goal was to solve for x. We did by using the law of cosine. So if you guys have any questions, drop them in the comment section below. Have a great weekend, everyone. I'll see you all next week. Bye.